For section 7.2, we are going to be going over internal and exterior angles. For the interior angles, I like to use this formula, kind of a formula or a reminder. You're going to do the big arc plus the small arc, and then in order for an arc to equal the angle, we need to divide it by 2. So I take the arcs and I'm going to divide them by 2 to equal the angle. So let's apply it and see how it goes. So I have my big arc plus this little cross in the middle helps me remember the plus sign. 54 divided by 2 will equal the angle in the middle. These will be the same size angle. That's why when I take this in, I can't say it's 54 and 180 because they should be the same size. So I add them together and I'm finding the average. So I'm going to do 180 plus 54 is 234. Cut that in half. 117 is equal to the missing angle. So you can just calculate because all of the values are on the same side. Let's try again. Question 2. Big arc. So big arc plus the small arc divided by 2 equals the angle. I have 123 plus 59. Divide that by 2. My angle is 91 degrees in the center. These two are 91 degrees. Question 3, big arc plus the small arc, divide by 2 to equal the angle. 125 plus 85 is 210, divide by 2 is 105 degrees for the angles that are located in line of my arcs. Notice they go in kind of a straight line. Question 4, I have my big arc plus the small arc. Divide by 2 equals the angle. So I'm going to do 165 plus 55, divide by 2, 110 degrees. 5, I do the big arc plus the small arc. Divide by 2 equals the angle. This time I have to solve. So in order to solve it, I'm going to times by 2. And then I'm going to subtract the 74. So basically on my calculator, I would type in 65 times 2, get rid of the 74 degrees, which means that the missing arc was 56. So this was when we found the arc. Before we were finding the angles, so we could just plug it in our calc. Okay, question 6. Big arc plus the small arc. Divide by 2 to equal the angle. I need to multiply it by 2. And then I get rid of the 130. Oh, sorry, that's wrong. It's not a 6. It's just 4. And it should be 84 degrees. So if I check it, I had 107 times 2 minus the 130. Whoa. Minus the 130. And that was our missing arc. Question 7. Big arc plus small arc divided by 2 equals the angle times by 2. And then minus the 127. And let's double check our work. We had 91 times 2 minus the 127 is 55 degrees for our missing arc. Okay, next question. Big arc plus small arc divide by 2 equals the angle. Question mark plus 55 equals, oops, sorry, I should switch my colors. $120. Then I subtract the 55, which gives us 65 degrees. And I'm gonna double check. 60 times 2, get rid of the arc, 65 degrees. These are interior angles. They're inside the circle and they cross on the inside. This is how I remember that we are adding. When they cross, they make a plus sign almost. What happens when they are exterior? When they are outside of the circle? I'm going to do big arc minus small arc divide by 2 equals the angle. So instead of a plus sign, I just switch it to a minus. Big arc minus the small arc divide by 2 equals the angle. That one I can just calculate. 123 minus 43. Divide by 2 is 40. Big arc minus the small arc. Divide by 2 equals the angle. 115. 115 minus 45. Divide by 2. 35 degrees is the missing angle. Big arc minus the small arc divide by 2 equals the angle. 125 minus 65 divided by 2 is 30. Big arc minus the small arc divided by 2 equals the angle. $60 degrees. Big arc minus the small arc divided by 2 equals the angle. I have to solve this one. going to times it by 2. Then we add the 50. This arc should be 160 degrees. Big arc minus the small arc divided by 2 equals the angle times by 2. Add the 23 over the 123. $187. Big arc minus the small arc divided by 2 equals the angle times by 2. Then I get rid of the 170. Now that's weird because it equals -60. It can't be negative degrees, and if you notice this was a minus question mark, you have to divide by -1, which means our question mark is 60 degrees. Or you can just change the signs, make them both positives. Big arc minus the small arc divided by 2 equals the angle times by 2. Then we add and get 190 degrees. Question 17. I have the small arc. I need the big arc, so I'm going to do 360 minus 104. Okay. Big arc minus the small arc divided by 2 equals the angle. I can just calculate that. 256 minus 104 divided by 2. 76 degrees. Same thing here. I want that big arc. So then I would do big arc minus the small arc divided by 2 equals the angle. $60 degrees. And I'm just going to be, this one's pretty difficult and you shouldn't get one this hard. So I'm just gonna use my 60. That means this would be 120 and this would be 240. I'm just using my previous question to fill in the information. Then on this one, I have the big arc. So the small arc is 125. Big arc minus small arc divided by 2 equals the angle. 235 minus 125 divided by 2 is 55 degrees for the missing angle. From there, we have some probability questions to review. What is the probability of landing on 1 or 7? Use my highlighters. Okay. Landing on a 1 or a 7. That would be 2 out of the 8. Or 1/4 if you reduce. Probability of landing on a number greater than 5. It cannot be equal to 5, it has to be greater than 5. So there's 1, 2, 3 numbers greater than 5 out of the 8. Numbers that are less than 6. Not equal to 6, but less. 1, 2, 3, 4, 5 numbers are less than 6 out of the 8. A multiple of 2. 2, 4, 6, 8. That's 4 numbers. 4 numbers out of the 8 are a multiple of 2. And if they ask for a multiple of 3, multiple of 3 would be 3, 6, 9. There's no 9, so I'm only going to have, I don't know where my purple pen went. Well, it's just gonna have to be blue. 2 out of 8, or 1/4 for the purple. Okay. What if we have a spinner and we have multiple probabilities? The spinner below is spun 3 times. If the spinner lands on a border, that spin does not count, and spin again. It is equally likely that the spinner will land in each of the 6 sectors. Find the probability of spinning a red on the first spin. 3 out of 6. Probability of spinning blue is 2 out of 6. And probability of spinning cyan, however you want to say it, would be 1 out of 6. And I'm going to multiply these probabilities together. So when I multiply them, they end up equaling 3 times 2 times 1, it makes 6. 6 times 6 times 6. 6 times 6 times 6. And then if I reduce it, one over 36. What is the probability of spinning a red on the first spin? Then the cyan on the second, and red on the third, so spinning a red again. I multiply my probabilities. 3 times 3 is 9. 6 times 6 times 6 was 216. Then I see if I can reduce it. 9 over 216, math, enter, enter. 1 over 24. What is the probability of spinning cyan on each? So that was 1/6, 1/6, 1/6. And that won't reduce. The last question is a review on trig. Just a reminder, we use so, ka, toa. I'm given this triangle I know that C is a 12 and A is 35. So when I draw my triangle, I know that C is a 12 and A is 35. If I want to find the missing angle, I know that A is 35. I know that C is 90. So if I want to find my other angle, I'm going to do 360 minus 9. Why am I doing 360? Sorry, I've been doing circles. A triangle is 180 degrees. (180 minus 90 minus 35) is 55 degrees. Now, if I want to find my sides, I'm given 35 and 12. I'm going to put an X here and try and find what A is. Actually, I'll just put an A. That'll be easier. I'll just put A as my variable. This is my opposite. This is my hypotenuse. And this would be my adjacent. Adjacent doesn't have a side number. I'm using so. Sine of my angle equals O over H. I then times by 12 and enter this on my calculator to find A. 12 sine of 35 is, I need to fix my mode, it's in radians, 6.9. Then if I want to solve for my other side, here's my 12, here's my 35 that was given. I'm going to look for side B. I know that this is O, H, and A. O does not have a side. That means I am using A and H. That is cosine of my angle equals A over H times by 12. And this is what I answer on my calculator to find B. 12 cosine 35. 9.8. So if I fill in angle ABC, side A was 6.9, B was 9.8, and C was 12. So we can find all of the sides and all of the missing angles.